So I'm gonna give you the center, that is 1, 1, and radius is 2, and find the circle equation and graph it. Graph it. Okay. Circle equation. Find the circle equation and graph it. Okay. Okay, I'm gonna write down the answer on board. Take a look. So we idea is um, very simple. We try to plug in all these three parameters to this equation, right? H equals 1, K equals 1, radius is 2. Plug in this equation, x minus 1, 1 minus 1, 2 square, right? Plug in, and then you're gonna get what? Get the 4, right? 4. Then you can draw a picture. And the 1, 1 gonna be the center is here, and you're gonna draw the radius. So here's 2, here's a 2, here's a 2, 2. So you can connect all these points. Very ugly, but I wish you guys can understand. The radius is here, okay? So here is 2 units, here is 2 units, here's a 2 units, here's a 2 units. So you connect all the points, okay? Connect all the points.
Okay, so I'm missing something. How did you get those points? I don't understand how you got the points from x minus 1 squared and y minus 1 squared. I mean, where did you get those points from?
how to get this 1, 1?
Yeah, how do you, I mean, you just have the graph, the 1, 1 on there or something?
1, 1 is the center, huh? Yeah.
That's what we had the graph, and then we just had the.
Radius, huh? Radius is here. Huh? You have a point and a radius. So the radius going to be goes around this point, right? That is 2. So any points around any points on the circle going to be the distance between the circle going to be what? Going to be so any points along the circle going to be the distance between these points on the circle and the center should be 2, right?
So level our.
So in on your MyMathLab, you just need to give them a point and a radius. They're gonna help you to draw this picture.
Okay, so basically I plot the center point in the unit. Then I move 2 spaces,
2 units.
2 units, all the
Yeah.
way around.
Yeah. Do you know how to draw the circle?
Yes, sir.
And then a center, a radius, blah 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 blah, hang around this center. Huh?
Okay.
That's it. Okay, so that's the that's the things we learned from last class. Okay, and chapter 3. Today we're gonna learn something different. Chapter 3. Functions and their graphs. Okay. Definition. Let x and y be 2 non-empty sets. A function from x into y is a relation that associates with each element of x exactly one element y. Okay, now let's take a look the definition of a function. The definition of function, the 4 things we should recognize that a function is a relation. Okay, that is a relation between the elements in x and elements in y. Okay, that's what. Then we should have another keyword that is 1. Okay, what does that mean? That means any element in X set corresponding to exactly one element in Y. One element of Y, sorry. So each element in X set has exactly one element correspondingly in Y. Okay, so we can draw a picture. That's the first case. We have two sets. Okay, we draw these two sets. And then we have elements 1, 2, 3, 4. And we have element in Y. Now, each element in X has exactly one element in Y set. Okay, for example, this element, we have one element in Y. This element corresponding to the this element in Y, and this element corresponding to this element, okay, and this element corresponding to this element. Okay, so each element in X has exactly one element in Y, exactly one element in Y. Okay, now let's take a look at another case. Okay, let's take a look. The second case. Take a look. Based on definition, we know the function will be one element in X should have another correspondingly one element in Y, right? However, let's take a look at this element. One element in X, however, we have two elements in Y. So that means this guy is not a function. Okay. Based on definition, one element in X should have exactly one element in Y correspondingly. However, in this case, we have two elements. Okay, two elements. You see it? Okay, in Y. For this case, although one element in Y, we have two elements in X, but that's okay. Based on definition, will only requires for the X, not requires for the Y. Do you see it? So this is a function. However, this guy is another function because this guy has two elements in Y. Okay, has two elements in Y. That's another function. Okay, so that means this is a keyword. One element in Y. Okay, one element in Y. That's the keywords. Try to understand this guy. Okay, now I'm gonna give you guys some examples. Person, phone number, then calling Phoebe, and for each person, we have phone number. Okay, so we have this guy phone number, and the calling has 2 phone number. Now I have a question: is that a function or not? That's not. Okay, you guys agree? It's not a function because what? The calling, the element in X has 2 elements in Y. Okay, 2 elements in Y. So that's another function. Okay, that's not a function. Now let's take a look. Another one. Animal, dog, dog, kangaroo, kangaroo, rabbit, we have okay. So how about this guy? Is that a function or not based on definition? It's not a function. Yes. Yes or no?
Yeah.
Yes. Right. Okay. Because you can see each element in X set we have correspondingly 1 element in Y. Right. This element has 1 element in Y. 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 Right. Although for Y element, this guy, we have 2 X element, but this is not required for the function. Okay.
So as long as it's one,
Yeah, 1 element, exactly 1 element in Y. That's the reason this guy is the function. I already show you, right? 1 element correspondingly, we have 1 element in Y. That's it. We don't require for the Y. We only require for the X set. Okay, X set. Any other questions? Clear? Very good. Very good. Now let's take a look at the second definition. The second definition is about the domain. The set X is called the domain of the function the set Y is called the range of the function okay. So let's take a look the for example the second example, the animal, dog, duck, kangaroo, and rabbit is the domain. Okay, the X set is the domain, Y set is the range. Okay, so for this example, domain should be what? Domain should be X set, should be dog, duck, kangaroo, rabbit. Okay, and the range gonna be the Y set, Y set, X, Y, right? X set is the domain, Y set is the range. You just copy it, okay? Copy it. 7, 10, 11. Usually if there's a number on your MyMathLab, please put from the smallest to the largest, okay? Put it from the smallest to the largest. That's the requirement from your MyMathLab, okay, MyMathLab. So that's clear. Domain and range. Domain means X set. Range, that means Y set. That's it. Okay. Very simple. Now let's take a look how to apply such idea or function to the realistic mathematical equation or the points in the XY coordinate system. Okay, so let's take a look. Example 1. For each relation, state the domain and range. Then determine whether the relation is a function. Okay, now the first example gonna be here. So I gave you guys a bunch of points. Okay, a bunch of points, that means we have X coordinate and a Y coordinate. Okay, then we can draw a picture. For example, we can draw the X set and the Y set. So for the X set corresponding to the is corresponding to the what? For the X coordinates. Okay, X coordinate for the X set. So X coordinate is 1, 2, 3, 4, right? 1, 2, 3, 4. 1, 2, 3, 4. And for the Y set, gonna be the Y coordinates. Okay. And we can see 1 corresponds 4, 2 corresponds to 5, 3 corresponds to 6, 4 corresponds to 7. Okay, and now you can see what is domain. Domain gonna be the X set. You just copy it from the smallest to the largest. Okay, so the value from here is okay, very good. It's from smallest 1, 2, 3, 4. And the range from the smallest 4, 5, 6, 7. Okay, now my question is that a function or not? Yes, of course, that's a function. Okay, one element corresponds one element in Y, right? One element always has one element in Y set. Okay, very good. Now I'm gonna let you guys try it. B How about this guy? Try. Tell me the domain and the range and determine whether it's a function or not. Please type your full name in the chat so I can check your attendance. Thank you. Okay, let's take a look at this problems. So for this problems, very similar to the last questions A. Question A, we just need to write down the X set and the Y set, right? X and Y. For the X set, we have X coordinate 1, 2, 3, 6, right? 1, 2, 3, 6. For the Y coordinate, we have 4, 4, 5, 10. If that is repetition, that means we just copy one, okay? So we have a repetition of 4, right? Repetition 4, we just copy one. Copy 1, 4. So 1, 4, 5, 10, okay? 4, 5, 10. So let's take a look. 1 corresponds to 4. 2 corresponds to 4. 3 corresponds to 5. 6 corresponds to 10. Okay, and it's very clearly the domain is what? Is 1, 2, 3, 6. Right? And the range should be 4, 5, 10. Okay, we just copy once if there's a repetition. Is that clear? Repetition, just copy one. Is that a function or not? Yes, that's a function. What? 1 to 1. One element in X, correspondingly, we have one element in Y set. Here, 2 corresponds to 4, 3, 5, 6, 10, right? So that's a function. Now, I want you guys to try this one for me. C. find the domain range and determine whether that is function or not. Okay, now let's take a look at this guy. This guy. Okay, so for the domain, we can draw the picture firstly. X, Y, Y. So -3, -2, 0, 1, -3. Oh, sorry. So -3, -2, 0, 1. We have a repetition for the -3. So we just copy 1. Okay, copy 1. We have a range 9, 4, 0, 1, 8. All right. Now for -3, we have one element in Y. -2 is 4, 0, 1. And we also found the last one is here, right? So we can clearly tell the domain for X set going to be -3, -2, 0, 1, right? And the range, and be careful, the range always starts with the smallest number to the largest. So smallest 0, 1, 4, 8, and 9. Okay, that's the format required by the MyMathLab. Okay, starts with the smallest to the largest. Okay, and is that a function or not? No, right? No. Very clearly, this element in X, -3, corresponds to two elements in Y, 9 and 8. Two elements. So that's not a function based on the definition. Based on definition. Okay? Very good. Very good. So now you guys has a rough idea about the function. About function. Now, determine whether the equation y defines y is a function of x. Okay, so determine whether this guy, equation y equals 2x minus 5, defines y as a function of x. How to do that? As we know, this guy is a line equation. This is a line equation, right? And we know the y-intercept is -5 and the slope is 2. So we can draw a picture. Okay, we can draw a picture. Let's take a look. So -5 is here and the slope is 2. So roughly you can draw the picture like that. This is -5, okay? Roughly you can draw a picture like that. Now, from the picture we can tell, if you pick one x point here, correspondingly, we can find only one y value. You pick one x here, you can find only one y value. You pick one x, you can only find one y value. We can pick one x, and correspondingly, we can find one y value, right? Is that clear? Whatever you pick one x, you always can find only one y value. What does that mean? Is that a function or not? That's a function, right? That's a function. So I give you guys the idea. Any line equation is a function. Is that clear? Because when you pick whatever x value, you always can find one y value. One y value. One x always correspondingly to one y value. So that means that is a function. A function. Okay, from this picture. Now let's take a look at another one. Okay, my question is whether this equation defines y as a function of x. As we know, this guy is a circle equation, right? Circle equation. We can draw the circle very quickly. Circle equation. Okay, xy plus y is equals 1. So now I draw this circle equation. Could you tell me, is that a function or not? From this picture, can you tell that is a function or not? It is? No? Yes or no? No. Okay, good job. The answer is no. Okay, why is that? Let's take a look. Because when you pick one x, you always can find the two y value. Right? We can find the two y value. You pick one x here, you can always find two y value. Did you see it? You find the one x correspondingly to y value. So that means that's not a function. Right? A function means one x always has one element in y. However, one x here has two elements in y. That means That's not a function. Okay, that's not a function. Question.
Is that true for all circles? Like
Yeah. So circle equation, very good question, is not a function. Okay, very good, very good. So I can give you the conclusion. Any circle equation is not a function. Now I'm gonna give you guys a very weird picture. Let's take a look. Now my question is that a function or not? Yes or no? The answer is yes. Why is yes? You just pick a one point x here, you always can find one y. One point x always can find one y. One point x, one y. One point x, one y. Okay, so that's a function. Okay, that's our one x, always you can find one y. You couldn't find two y, right? Right, one x, always you can find one y. Now let's take a look. Another example. How about this guy? Is that a function or not? Of course it's not, right? Because you can find here, you pick a one x here, you can find how many? 1, 2, 3, 4, right? You can find 4 y elements. If you pick a one x here, you can find 2 y elements, right? So that's not a function. Very, very straightforward. Well, just pick the x, check the y value. How many y values? You can find, sometimes we can find 3, sometimes we can find 4, okay? So that's not a function, okay? Okay, now let's move forward. After we know the function, then we needed to know how to calculate the value of y. If I give you the x element for the function defined by fx, evaluate okay, let's check this one. How to find the value of f1, okay, given this function. How to find the value f1? The point is substitution. That's right. We're gonna, here is 1, here's x, right? So we're gonna replace the x by 1. Okay, so what are we gonna do is replace this x by 1. That means this x, all replaced by 1. Okay, by 1. So 2 times 1 squared minus 3 times 1. Okay, and we can simplify it. So replace this x by 1, replace this x by 1, replace this x by 1. So 2 times 1 square minus 3 times 1, okay? So 1 square gonna be 2, 3, negative 1, okay? And for example, okay, I put it as a negative 3, f negative 3, okay, more challenging if I put a negative number there. So how about f negative 3? The same things. Replace this x by negative 3, right? So we have 2 times, be careful when you plug in the negative value, you always put the parentheses, okay, in case you make a mistake. Negative 3 square minus negative 3 times negative 3. You see it? Replace the x by negative 3. Put the negative 3, put the parentheses for the negative 3 because it's a negative number. Okay, always put a parenthesis there. So now it's much clear. 2 negative 3 square gonna be positive, right? Negative 3 times negative 3, negative, negative, positive. 2 times 9, negative 3 times negative 3, will be 9. 18 plus 9, 27. Okay. Now I want you guys to try f negative 2. Try it by yourself. Okay. Very good. Now let me try it. I think most of you guys should get it. Now let's do it together. So that means replace this negative 2 by, replace this x by negative 2. So here, 2x replaced by negative 2 square, negative 3, x by negative 2. All right, first step. And 2, negative 2 square, 4, negative 3, negative 2, 6, 8, 6, 14. Okay, 14. Do you want more examples or let's just move on? More example or just move on? Do you want more example? You're good. Oh, very good. Now let's continue. The D. Calculate fx plus 1 f negative 1. Think about it, how to solve this stuff. Fx plus f negative 1. Aha. How to solve this stuff?
Just be, if you substitute the x for -1.
The good thing is substitute the negative 1, right? So let's take a look. Let's take a look together, okay? So for the fx, we already know that is what? 2x squared minus 3x. Right? The first term we already know. And for the second term, is what? Replace the x by -1. Okay, replace the x by -1. So we have 2 -1 squared minus 3 -1. All right. What are we gonna get is 2 times 1, 3 times -1 is 3. Because -3 times -1 is 3. So it's 5. So the idea is for this guy, just plugging in, right? Fx, 2x minus 3x, right? Just copy it. And f -1 is what? Is 5 plus 5. That's it. Just plug in. Right? Don't be scared of such mixed stuff. Okay, don't be scared of anything like that. Now, E. What is 2fx? Think about it. How to calculate 2 times fx?
Is it x squared?
No. 2 times fx. Okay, I'm gonna show you. Some of you may have some trouble. 2 times fx. What is fx? Fx. Very good. 2x squared minus 3x. Okay, that's it. Fx is what? Fx is 2x squared minus 3x. So 2 times the whole thing. Be careful. The whole thing you need to put a parenthesis in case you make a mistake. Okay, 2 times the whole function. So that means 2 times, put a parenthesis here in case you make a mistake. Okay, so just plug in the fx and the distribution. So 4x squared minus 6x. That's it. And now I'm gonna give you guys an example. Let you guys finish it. 3fx. Try this one by yourself. Okay. You get it? Okay, let me write down the answer on board. So 3 times fx. Fx is what? Is 2x squared minus 3x. Right, that's it. Just plug in the fx. That is the multiplication of a polynomial, right? That's what we learned before. It's a very straightforward distribution, right? Distribution. 3 times 2x squared plus 3 times negative 3x. 6x squared negative 9x. That's it. That's it. Okay. I'm gonna wrap it up class here. Thank you for coming. Have a nice day. Okay. Make sure you understand all the material that you learned from this class. So next time you will not forget it if I mention it again. Okay. Thank you for coming. Have a nice day. Keep healthy. Okay.